Good morning everyone. I am Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this particular video lecture series, I am going to explain about the frequency division multiplexing. Multiplexing is nothing but the process of combining more input signals and while receiving it will get it as a single signal, that is multiplexed signal. If there are two types of multiplexing, one is time division multiplexing and another one is frequency division multiplexing. I have explained about time division multiplexing already. Now in this lecture series I am going to explain about frequency division multiplexing, where the multiplexing is done with frequency, that is called as a frequency division multiplexing. um, the most common technique used is a frequency division multiplexing. This technique uses various frequencies to combine streams of data for sending them on a communication medium as a single channel. Example, a traditional television transmitter which sends a number of channels through a single cable which uses the FDM. This is nothing but a simple block diagram of a frequency division multiplexing, where various channels are combined in the multiplexer's side, and those inputs are being sent to the demultiplexer side, but with using various frequencies. How does this frequency division multiplexing work will be seen now. That is, a number of signals are transmitted at the same time and each source transfers its signals in the allotted frequency range. There is a suitable frequency gap between the two adjacent signals to avoid overlapping. Since the signals are transmitted in the allotted frequencies, so this decreases the probability of collision. The frequency spectrum is divided into several logical channels in which every user feels that they possess a particular bandwidth. A number of signals are sent simultaneously at the same time, allocating separate frequency bands or channels to each signal. It is used in radio and TV transmission. Therefore, in order to avoid interferences between two successive channels, here guard bands are used. This is the block diagram of FDM transmitter and the receiver, where we'll be using various signals with the modulating and the carrier frequencies, and it is being given to the mixture and then to the communication channel, where here a particular, that is a composite signal, is being combined and it is being given to the communication channel with various bandpass filters. Here the filters are used to filter the unwanted frequencies and send back the original signal to the demodulator, and finally will receive the original signal here, where the FDM transmitter here it does nothing but the numerous signals that are to be transmitted along a common channel modulate different frequency carriers in the modulating section. The output of the modulator will have multiple signals of different carrier frequency. The modulated signals are then fed to a linear mixture which is different from a normal mixture. Linear mixture simply produces the algebraic sum of the generated modulated signals. The combined signal at the output of the mixture is then transmitted along with the receiver. FDM receiver. Here the receiver section will have a composite signal that was transmitted by the linear mixture over a channel. This composite signals is then fed to the different filters, mainly to the bandpass filter, each having a center frequency corresponding to the carrier frequency. The bandpass filter passes the channel information without any distortion. So after demodulation, we have separate signals that were actually transmitted over the same channel. The main advantages of a frequency division multiplexing are efficient use of bandwidth, no synchronization time is required, and a low implementation cost. This frequency division multiplexing allows multiple signals to be transmitted over a single communication channel, which can lead to more efficient use of available bandwidth. For the synchronization, it does not require precise time synchronization between the transmitting and the receiving devices, which makes it easier to implement. Then implementation cost. It is relatively simple technique that does not require sophisticated hardware or software, which makes it expensive to implement. The various drawbacks are it has a limited capacity and it also has an interference, and it is difficult in assigning frequencies. FDM requires careful assignment of frequencies to different signals in order to avoid interference, which can be a complex and a time consuming process. The main applications of FDM are in the first generation of the mobile phones, this frequency division multiplexing was used. The use of FDM in a television broadcasting signals, and it is also used in broadcasting FM and AM radio frequencies. Assessment. Let us discuss about the definition of frequency division multiplexing. How does the crosstalk occurs in FDM, and what is the use of that, and mention the uses of broadband in this frequency division multiplexing. Thank you.